So, question 8, and part 1 was kind of interesting. Okay, so they have given you 3 probability density functions, and they want you to list down the standard deviation of these functions in, starting with the largest, so in decreasing order. Now, your standard deviation basically is like how much you deviate, like it's a measure of how much you deviate from the mean. Hopefully one thing should be kind of obvious to all of you, is that the mean for all of these functions is 0, because when it's symmetrical, and it has 0.5 on one side and 0.5 on the other side, and because it's symmetrical, your mean and your median would be in the middle, that is 0. So now you just have to figure out which one of these functions, probability density functions, has a lot of deviation, has the most deviation, and then you work yourself backwards from there. Now understand here, when you look at area, again, area under a probability density function does give you probability. So the more area is packed towards the side, towards the extremes, means the more probability is packed towards the extremes, which means a lot of your information, a lot of your probability is towards the extremes, is really far from the mean. And that's what you want to find out, the function with the largest let's say standard deviation. And just to explain this, let me first draw something. Okay, so let's take 2 functions, right? Let's say they both have the same mean at 0, and like one of them, like if I draw a very weird function, like something like something like this, yeah, it's bad drawing and it probably wouldn't never come in a question, but like you have one such function, and then you have a function like this. Like, so note, in the one on my left, most of the probability, most of the area is just packed right at the mean value. It's closer to the middle. Here, a lot of your probability, a lot of your area, a lot more of it is towards the sides, towards the edges. So the standard deviation of this one, well, it would be, if I call this y and I call this x, so standard deviation of y should be greater than the standard deviation of x. The reason being, because for y, a lot more of your probability is like far from the mean. It deviates more from the mean. It's towards the edges. So what we want to see here is which of these functions has the most amount of area under the curve, or the most amount of probability rather, packed towards the edges and far away from the mean. So to figure out the one with the largest standard deviation, you can like kind of eliminate these two, because, well, obviously they do have a lot of their probability does lie like, right, like really close to the mean. Like a lot of the area is very close to the mean, as you can see. Here, really close to the mean, well, you have 0 probability. So with x and z, both of them have a lot of probability, a lot of area towards the extremes. Which one is more? Well, z should be more, because simply if you look here, because this is curving upwards, so the area at the absolute extreme points, well, that's going to be slightly more than the area here, because this is just a straight line. It's not, if this had like if this had been like x, if I draw it here, it would have gone somewhere around this, giving you more area at the extreme points. If there's more area, more probability at the extreme points, then there's a larger standard deviation. So this has the largest standard deviation, and this is your second largest because of that logic. Because you're looking basically for a high amount of area towards the edges, towards the extremes of the density function. For this, well, if you just take a random value and look at area at the edges, this is very low. If you take area here at the edges, well, it's still obviously low compared to like x and z, but it's still much better than w. Like, so area of y at the edges, or if I'm just taking like rough values, like, but just look at it at the edges, the area there is a lot more than it is in the case of w. Because of that, this would be the third largest standard deviation. and this would obviously have the fourth largest, or a better way to put it is just the smallest. And there you go. They wanted you to list down in order, starting with the largest. So you have X, then you have Z, then you have Y, and then you have W. And there you go.